What's up guys, and welcome back to the ArchiTech Network. And today we're back with our ArchiTech tours on a beautiful London day, as you can see. And we're at the one and only Foster & Partners here in London. Now this is their office, but it can actually be described more as a small village. A lot of these buildings around are all part of the Foster's complex. We're going to be going in to talk to their ARD team and listening about some of the technology that these guys are working on. But I'm soaked. Let's stop, get inside and check it out. Alright guys, we're here at Foster & Partners with the one and only Marius from the ARD team here. Marius is one of the partners in the team. Maybe you want to introduce yourself and the team
absolutely.
a little bit.
First of all, welcome, Foster & Partners. My name is Marius. I'm a partner at the Applied R&D team. So today, hopefully we're going to show you around our campus and talk about technology, I suppose, or any other topics that Oli comes up with. So maybe we should head on.
Yeah, let's go.
So now we're heading to the main studio. So this is I think it was the first part of our campus here in Battersea, and it's still part of the campus. And this staircase leads to our open plan
I like
office desk.
The epic walkway.
Yeah,
in.
it's quite grande. We have a small cafe here. We can get food and beverages.
This is
So this is the Bloomberg headquarters. You might have seen the building in the city.
Very nice building. Incredible facade.
Amazing building technology.
Super green building.
Right, yeah. So this is the main studio. This is where all the central design teams that are supporting the architectural teams are located. Anything from design communication, visualization, graphic design, our very own applied R&D team.
Down there somewhere.
Yeah, further down at the end. And obviously, it is an open space. We have meetings on the side table. It's very integrated. You can go to someone's desk. For example, you can go to the structural engineering team and just ask them something. It's we're just next to each other.
It's actually super nice having that breakout space, because I think we always get jump into a meeting room, they're all books. It's really nice to have that kind of breakout space.
Okay, let's go to the side.
Yeah.
So I head up the film and visualization team within the practice. So we have 35 people within my team. All the production team set up in the main studio, so all the 3D artists. So down here, what you can see down here is the editorial team. So down here we have 4 editors and 2 cameramen. So essentially, once all the 3D content's done, so we can do anything from live action films, so filming our sort of projects, whether it's post-occupancy or on-site, or we can do a lot of work where we do competition films. So it's working with the architectural teams, trying to do pitches for new work, essentially. So it's really becomes part of the briefing documents now. You need to do a film for these projects, pretty much. Most of the key ones,
Is there any particular software that you guys are into now? For example, Unreal, is that kind of maybe at the core of what you guys do, or?
Yeah, so I mean, again, like a lot of firms, we'll use lots of DCC packages, 3S Max Maya, but we have a team dedicated to using those sort of DCC tools. We use Nuke for compositing up there, and then we have a separate team using Unreal, so our real-time team. So we brought the games engine in when we did Apple Campus, and we put the whole of the Apple Campus in a games engine. So that's when we did it a long time ago. It was CryEngine at the time, but then we switched over to Unreal. since. And then we have another team which is motion graphics. So again, communicating these complicated designs and elements of the complicated designs is really tricky. So, you need to do it so a layperson can actually understand the scheme. So the motion graphic plays a key part in that side of it.
Basically, this is our sketch model shop. So it's a place where every designer in the practice, every architect, from architectural assistant to at the partner level, I suppose, they can come in and they can prototype physical models.
The laser cutters. And
there's an abundance of apparatus, from laser cutters, zoom machines, anything down to simple foam making cutters. Again, a lot of materials at the disposal of the designers. So if you want to mock up something for your design proposal, you just come down here, you make it, you see how it looks, and you propose it. It's being reviewed. So the normal design process that you would do in the university still exists here.
Yeah. I think this is like where you're christened into the design process, right? We often have like a lot of DAs, design assistants, part ones come in here, and I kind of get the sense it's part of that beginning process of joining.
Yes, and physical models, it is true they are essential. Even though we have so many visualization tools and technology has progressed so much, there's still like something that is tangible. You can place it on the table and immediately you can even assess areas if you want to, like if you color code blocks, for instance. So it's a very quick way to provide this intuition and this feedback to your design, I suppose. So that's why we have all this big space for our designers. And also like there are members of the support teams that are professional model makers. They're here to assist with anything, any complicated tasks, let's say, or any specific needs, or to recommend materials that people can use for specific designs. Well, this is where we have all our 3D printers.
Wow, These are serious, like the powder printers, right?
Yeah, these are powder printers, and they're printing in color as well. And we have nylon printers here. They're, most of the time they work full on, like overnight, to deliver designs that can be reviewed the next morning. So
do you have more of the ulti-makers, like the desktop ones as well? Or?
I've seen a few flying around, but they're kind of hard to maintain. So it's better if, since you have these facilities here, you don't have to deal with preparing the files to be ready to be 3D printed yourself. So this is being handled by the professionals, I suppose. So you get away from this process of actually preparing the file yourself.
These do look like big boy printers, these ones. Blue foam,
which is now.
This is also.
It's I don't think we ever used blue foam. It's always white foam, I have to say. I haven't been here many times, but I never saw blue foam, to be honest. We prefer white as a practice, I suppose.
It's definitely another christening of every architect is to go through the blue foam or white foam modeling process. Do you see you guys mostly print with the powder printers rather than
a mixture? So we've got two big SLS machines. Print with like a nylon powder. Then we've got the color jet printers that print with a gypsum powder. So all of the color models are on these ones. So they're quite fragile, but they're good for like massing, and they're quite quick, so we can fabricate stuff for the architect like next day. And then we've got 3 smaller machines, like a smaller build volume with a resin. So that takes paint really nicely.
And you can get super fine with these ones, right?
Like down to 0.4. And then you have a lattice support structure. So this is all sacrificial. We would get rid of that, and that's what's attached to the platform. So it grows off the base. And then you remove all of this lattice work and you're left with your part. But you do see a witness where the nodes, see they taper down
like
to
little dots.
Like a little point. And
right.
It just tickles off, basically.
So this would be, Marius, you you're scripting this part.
Yeah.
You send it to you.
Exactly.
That's
the workflow.
That's the Lucille stadium.
The Lucille
the
stadium.
cutting.
Yeah.
So this place is first and foremost a materials library, and we have over 25k samples. And then I think the purpose of this place is to provide a knowledge base for the practice on materials, products, technology, sustainability, you name it, processing. And we could get asked anything on a regular basis. The architects will come along, say we're working, whether it's a competition or it's a fully fledged, project. What's local materials? Yeah. What can we look at? And then what are the craftsmanship, the technologies? What can we do with it at the end of life? And you can see here, circularity is a very important facet. And what can we look at? But we're lucky that we get an awful lot of architects and companies and, all working with us to try and push things. Yeah. And that's what it's about.
I have to say, this is one of the most impressive material libraries
Thank you.
I've ever seen.
But it is, like I said, because we have a range of people, and I've got such a plethora of knowledge and expertise. So it's important to stress that. And we try and do sort of CPDs, exhibitions, as you can see. But it's all at the forefront. So what you're seeing there is calcine clay, which is the latest in low embodied carbon concrete. But that's what I say, people coming to us. But we're also going out there to say decarbonisation, what is happening in concrete, in glass, in steel, in aluminium. And that's all of the work that my team and I do.
My name is Martha Tsigkari. I'm the head of the Applied Research and Development Group at Foster & Partners. I'm a senior partner at the office and have been here for 18 years.
Well, Martha, thank you so much for having us. The tour was amazing. I'm always blown away by this village that you have here and like some of the facilities you have.
University.
Yeah, it's mind-blowing. Maybe start by introducing the ARD team at Foster & Partners and what the kind of disciplines that you currently cover in the team.
Before I start with the applied R&D, it is important to understand how we work as an office. So the office is an integrated practice, which means it has a lot of different teams that work together from conception to completion, everything in between. So we have our own engineers, MEP, our own product design, people who do film and visualization, have you seen, urban design, landscape design. And within that spec, we also have the Applied Research and Development Group. Our group has historically been very small. We are often 1% of the entire company. So now that the company is around 2,000 people, we're around 24. Yeah. And it's a very interesting mix because all of our backgrounds, most of our backgrounds in the past was architects, engineers, and our common denominator was that we knew how to program. We had some sort of computer science degree one way or another. But now we're expanding our group to include actual software developers, back-end, front-end, full-stack, data scientists. But we do have the odd artists, for example. Yeah. We like to mix and match, and we like to bring a lot of passion and different disciplines together in order to be able to solve interesting problems in fascinating ways. One of the things that is important also for us to understand is that we perform in different areas of expertise. So our bread and butter 15 years ago was complex geometry, and that's how we started, with complex geometry and fabrication, with parametric design back in the day. Yeah. But obviously, as technology evolves, we evolve too. And that's also part of our remit. We need to see far in the future to see what's going to come 5, 10 years from now, and not necessarily just within our industry, but any other industry outside our own. So now we focus on a lot of different things with performance-driven design optimization, writing our own analytical tools that run in GPU, for example, and creating our interactive application that allow for real-time performance-driven design to be available to the designers in the studios. We are doing a lot of things around interoperability, so connecting different software together in real time for people all over the world. We have been focusing quite a lot on AI and machine learning for the past 5-6 years, developing applications for the office that are going far beyond Gen AI, which is what everybody's speaking about right now. A lot of investigations around extended reality, so augmented and virtual reality, and that has taken us almost for my entire career here. We have been investigating what is the new headset and what are the applications that we could do in relation to what we were seeing was coming towards in the future. And we have been doing a lot of things around digital twins, smart cities and smart buildings, having developed our own IoT system, robotics. We were the first architectural practice that had Spot in-house and used it on a proof of concept. That's a little bit of what we do.
You're really... So you're covering a lot of disciplines,
Indeed.
Which is super interesting. Maybe one question, like, one problem I always had is there's so much going on right now. How do you know what to focus on, or how do you prioritize some of these things, like AI is popping up, or there's new things in AR or VR? Like, how do you determine what to follow?
It is part of the job description, right? To be able to identify these things, and you need some experience and, dare I say, some talent. I'm not talking about myself. I'm talking about an entire team behind me who's supporting that, and they're all extremely talented people. And we are... The interesting thing about people in applied R&D is that they have a lot of different interests, and they're looking into a lot of different things all the time. So we have an overall strategy about things that we see, and because we are in different domains, we know that they're going to pick up. But also we get different ideas from people coming in and suggesting, oh, maybe we should be looking at that. And the main thing, what I think makes us really powerful in that respect, is that we are looking outside our industry first and foremost. When we started looking into AI back in 2017, we were looking into machine learning and deep neural networks that were all the rage at the time. And we're trying to understand what can we do with GANs? How can we use them in our process to facilitate and augment what we do in the office? So it was not even about Gen AI at the time, or ChatGPT or Midjourney. So identifying things, seeing the prospect of what you can do with them, and reimagining how the industry can work, that is part of our remit, and that's what excites us and makes us do all these incredible things.
That's where the magic happens.
Hopefully magic, yes. At least for us it is.
Yeah, sometimes it does feel like magic when you hand these tools to designers. So it's exciting.
As Arthur C. Clarke said, any sufficiently advanced technology is indistinguishable from magic.
Maybe talk about how the ARD team works with the project teams. Like, for example, if I have a problem, do I come over and tap you on the shoulder and say, I have a problem with this script or something? Or are you kind of overviewing the office from a kind of broad view and seeing where you can implement new things?
We do both. And I think that is where great things happen, because you cannot... We have been investing quite a lot in developing products and services within ARD that we deploy office-wide. But of course, you cannot deploy good enough products or services if you do not really understand what your designers need. And that's what we have been very, very good at doing. We are involved in projects on different stages, for shorter kind of firefighting involvements, or really long-term ones that may last for years. And through that, we can really understand where the pulse of the designer lies, what it is that they need, what are the problems that they're facing, and what are the best ways that we can solve them. And what are the different ways that we can solve them as well. So we do quite a lot of project support, sitting with the designers, understanding what they want. And based on that, we educate ourselves in what is needed, and we build up our capabilities and in relation to the things that we know, if we put in their hands, will make their job easier and their life better throughout the day.
I think one of the nice things about being on the tech side of an architecture firm is you probably get to see all the products, whereas some of the designers maybe just see this project, and then 6 months, 2 years later, they see this product. So
our office is really good at trying to create an overview for everybody, so people can have different experiences and understand different projects altogether, despite of where they're working on. But I think, yes, absolutely, what you say is right. The fact that we are coming in as, I would use the term support group, but I don't really like the term, but as a facilitator in many ways, that is helping us see all different scales and all different stages of the project, and also deal with a lot of different problems and issues and challenges, which we find very interesting on a daily basis.
So you mentioned you've been at Foster's since 2006. You must have seen some, amazing development in technology over the years. How have you seen technology grow, but also play a role at Foster's over that period?
The interesting thing about Foster and Partners that also had captured my imagination before joining the office was that technology was at the heart of how the office operated. That constant idea of reinventing what architecture is and what it can do is at the heart of what we do, along with sustainability and a human-centric approach to design. So that has always been the case, and it's interesting because as an office, we don't shy away from using new things, trying new things, and deploying new things. And that is what makes us, I think, quite interesting. We have both the know-how and the resources to do that, but also from the top down, the need and the support to keep on doing it. So things obviously change as technology evolves, but at our heart, we have always been an office that has been really rooted in technological advancements.
You guys have created some amazing software, and I've had a few little sneak peeks in shape to fabrication when you showed a few of them. I think you've got Hydra, Hermes, and Glaucon, if I pronounce them correctly. How long does it take you to? They're amazing.
And we have more than those, just to be clear.
some extra ones. How long does it take to develop those and go from the idea that we need this tool to implementation in the office?
It takes a long time until the point that you realize that you need to develop something, because what happens is somebody comes with a question and a problem, and you try to solve it, and then you see 2, 3, 10 more people come with similar issues, and then suddenly you realize you have something that is a replicatable issue that deserves a good solution. At this point, you start investigating what the solution might be, and you start thinking what is out there, what exists, and how can I tap again in technology that can help me, that does not necessarily exist within the industry today. Right. Cyclops, which is our ray tracing software that is using GPU computing and can run really, really fast, for example, was born from this idea of how can we do views very quickly. And then how can we use them in real time? So how can we develop an engine that can run in real time? Okay, let's use GPU computing as it's used for video and games. And then realizing that, okay, now when we're doing views, this is a ray tracing exercise. How can we extend that to environmental design? So this is how these things develop on a technical level. But at the root of these things is always the designer. So what do they need? What are the actual problems that we try to solve? Because I find that the biggest problem in the industry, in people who do similar things within our industry, is that we're always so enamored with what we're doing and how cool things are, that we fail to see what is the actual problem that we try to solve, and we're following on trying to just do things that are exciting. So for us, at the root of how we operate is actually going out there, speaking with designers, and doing proper customer research in understanding what they need and what are their roadblocks right now and what they would like, without even telling them what we're trying to develop, just by understanding whether the assumptions that we had on the software are correct. And after we do this customer discovery, we start developing the software on top of that, and we give them to trial, and we're trying to understand what the right UX, UI is and all that. But always with a mind towards how we can facilitate them and whether we're solving the right problem. And I think this has been permeating the development of both our products and services for a few years now.
Yeah, you've built some amazing software. Will we ever see some of these outside of the walls of Foster's?
It's interesting what you're asking, because many years ago this would not be a discussion. The answer would be no. But right now we are really investigating what the value of the software is in terms of opening it up to the world, and always in conjunction to how this would potentially jeopardize our commercial IP and competitiveness. In some cases, there are software that we would like to keep in-house, but there are opportunities for software software to be more exposed. And these are conversations that we're now having with our executive board. There's no answer yet, so everything inside for now, but we'll see how things evolve and develop as with everything in the office.
Obviously, I've got to talk to you about AI because we can't not mention it at this era that we're in. No, I've listened to a few of the talks that you've brought it up, and maybe this will be a two-part question. One is, how have you seen AI affect the design process so far, and maybe I know you already mentioned the image generation side, which is somewhat the kind of the new toy that everyone's playing with, and then there's the kind of more interesting side of large language models and Gen and all this kind of stuff. How are you seeing AI play a role in the design process?
I think AI is going to be instrumental, again, on reinventing how we do design potentially in the future. But I also feel that right now in our industry, there is an approach on a very superficial level. And that can be problematic in the future because we need to really understand in depth what machine learning and AI can offer us throughout our process and how we can control the discussion and the situation so that this becomes a tool in our hands to enhance our creativity rather than replace it. To that end, we have been developing quite a few tools that have to do with surrogate models. For example, how do you train a model to predict analysis in real time rather than run the analytical process? Or we have been using large language models to create our own search engines that search through our documents. We have been using it for business purposes, and even we have been looking into, as you said, image creation, but not just random image creation, but we have been developing applications that are incorporating within our design software, like Rhino, where as a designer models something, they can ask the AI agent to superimpose some sort of a rendering on top of the model that actually exists rather than trying to imagine something. I think it is important to understand that there will be a transformational change in how AI and machine learning are applied, particularly with the creative industries. And I'm yet to see quite a lot of discourse around in-depth issues on how we're using it in our process. Nobody is speaking really about copyright and IP, which are significant issues. And they're not necessarily something that is going to stop things from happening, but we need to consider them as we move forward. Nobody's talking about what is the value that we as architects are bringing on the table when AI and machine learning are going to automate a lot of the things that potentially we're doing, and how does this value needs to be shifted. There are a lot of very interesting things up for discussion right now, and I hope there's more of that coming shortly.
Everyone that I speak to in practice is really about how can we utilize AI to enhance what we do. I know there's a bit of a fear of people just typing in what they want, they create an image, and now I have a building of it. But I think that's, as you mentioned, that's really where the future's going to be, is this human and artificial intelligence combined, creating something that we may have not seen before.
Well, that's why I'm telling you, everybody kind of talks about image creation or using ChatGPT to get some answers, right? And I think this is just literally scratching the surface. It's going to be not even years, even months, where we're already having models that can go from text to 3D models, from text to mesh, that can automate processes, that can create interfaces, that can catch different APIs and create workflows. All these things are going to fundamentally change the way that we do our pipelines, the way we work. And it's going to be far beyond just imaging and having an AI agent give us an answer to a question. We need to really consider all these changes and see how we can be part of the change in order to see the change we want to bring forward in the industry.
Maybe on that note, not only on AI, but like for a young architect listening to this and has dreams of one day joining your team.
Are there architects like that out there dreaming to join?
Of course, yeah.
Right,
I think definitely for myself, when I was at uni, I think Foster's had that kind of your specialist teams, and I was always really blown away by the tech side of things, and I didn't see that in every firm. So for sure, there's architects wanting to join your team.
I've just asked the question because I like hearing it. Hearing the answer.
One, what kind of qualities do you look for when you are hiring maybe young architects that have just graduated, do they need to code? And two, with this rise of AI, what would you advise for young architects to get involved in this and not get kind of left behind, so to speak?
So one of the major denominators of every hire is that they need to be good programmers. They need to have at least good expertise in one language. We have certain languages that we prefer over others, but we're very open to that. So this is something significant for us because that's the way that we communicate and we develop things with each other. But I think in parallel to that, what we value very, very highly is potential. You don't need to be the best programmer out there, but you need to have the potential to know how to work well, to understand things, to bring ideas on the table, and to like working on a team. And even more importantly, to see that the team is above all. We're not really looking into having everybody showing themselves, being lone wolves that are doing great stuff. The power that Applied R&D and Fosters, I think, has is that we're working as a team. Yeah. And if the team works great, everybody's elevated, and that's what we're looking into people, that sense of potential, that sense of camaraderie, and that kind of, I don't know, blink in the eye that, you know, they get it and they want to do something great.
Yeah. I really like your new team shot where you're sitting on the I-beam in London.
I think it's important to, I can't say enough about the importance of the team. I mean, my team in particular, and the great talent that exists there. We're all kind of coming to you speaking, everybody who's speaking, they have a team behind them. We should not forget that we're not individuals who develop these things. Architecture is a group sport, right? Yeah, yeah. And it's the people of the team that create the power for us to do great things. So I can only say that my team's amazing, every single one of them, and that's why we're able to do great things. And the same thing for Foster & Partners. Now, going back to your AI discussion, it's not only about AI, it's about every single technological advancement out there. Yeah. The trick is to actually understand in depth what it is that it's doing, to not have a superficial view. So that's what I would suggest. Don't try to just listen from your kind of reflective mirror of social media of what is important, what is not. Delve inside yourself. Try to read as much as you can. Understand in depth what it is that any given technology is doing and what it has the potential of doing. And only then you will really grasp the opportunities and the possibilities within the industry. Otherwise, you're just saying again and again things that you hear. It's like an echo chamber, and that doesn't really help anybody.
So final close, as we look towards 2024, I feel we're in a very exciting time in the tech space. There's AI going on, game engines, all this kind of stuff. Is there anything in particular you are personally excited about that you see on the horizon?
It is a very interesting question because I don't have a particular answer to that. What excites me is the idea of change, the idea that we can constantly reinvent the way that we do things. That's what excites me. And the tools are so many out there, so many things that you don't even thought about a year ago, and suddenly it becomes a thing that you absolutely need to see. So I've never kind of picked up a player or two and said, oh, this is what you should look at, this, because I think if you are trying to play the medium, it's a bit of a risky profession. I want to effectively see how all these things that exist right now, all the things that I mentioned that my group is already looking at, how they're going to be able to differentiate our workflows, change the way we approach design, and how the entire profession is going to be is constantly evolving and is going to be further involved through these technologies. So my excitement is that sense of constant change. And that's also what Norman Foster says all the time, the only constant is change, and that's what excites me.
I'm Adam Davis. I'm a partner at Foster & Partners and deputy head of the Applied R&D team.
So I think you're also very unique. Like Martha, you've been at Foster since 2006, right? Mm-hmm. So I think there's something really interesting how you've seen technology evolve over your time at Foster's, particularly now we've got everything going on with AI and all these other kind of things, but how have you seen technology evolve over your time at Foster's?
Well, I mean, one major force is commoditization. So when I started, parametric design was still a niche pursuit. I think it's safe to say. we were creating bespoke parametric design systems. Along came Grasshopper and Dynamo and other systems besides. And we have had occasion to use all of them, some of them in to considerable lengths and depths. And at one level, it enables the sort of the tide lifts all boats. Yeah. It enables everyone, not just within our team or within our practice, but everyone in the industry, everyone in the world, to do things with a speed and fluency that they previously wouldn't have had. Even we wouldn't have had, partly because we were constantly having to build the tools that we were using. Yeah. So it gave us a level of power, an ability to address some very particular concerns. But there was always this challenge when you're both a tool maker and a tool user of having to wear both hats and do both things simultaneously. So yes, I think that commoditization and it's parametric design is but one example. We've had some similar experience with virtual reality, extended reality. Some of our former team members were working on virtual reality systems well over 20 years ago, with hardware that was, on the order of £50,000 a person per seat per user, and we're now doing far more advanced things with headsets that cost a few £100. And so sometimes you have to wait quite a while for those. The parametric example was a smoother transition, whereas I think the XR one, there was almost a trough, or they talk about winters of technology. I think XR really did have quite a winter, and perhaps a long winter as these things go, and then the green shoots all of a sudden just burst into bloom, or whatever the metaphor you want to use. But it's just been this incredible. Just incredible acceleration of technology in that space.
But you have a bit of a mix of areas of expertise. You've kind of obviously got that computational and parametric backgrounds. More recently, am I correct, you're working also in the world of virtual twins and this kind of space? Like, what are the kind of areas of expertise you've had in ARD?
Sure. I think the way I would maybe the hook I would try and hang it on is that I'm very interested in user-centric design, people-centric design. Yes, parametric design. Fairly early on in my time here, I began working with what we describe as quality of view, and developing both tools, but also standards by which we might understand what it means to have a good view, what it means to have a less good view, what it means actually to have what we might call a view annoyance, or something that you don't want to see. Overlooking is perhaps the most common example of that. In most contexts, people don't want to promote overlooking, although interestingly, as a practice, we have had some situations recently with designs where celebrities are going to be in attendance. We're actually promoting, a view of so-and-so or a glance of so-and-so becomes an important activity. But nonetheless, there's understanding that in an objective manner, and then there's also opportunities to understand that in a subjective manner, or trying maybe to understand not simply quality of view, but qualities of view. So how would we describe it categorically, or maybe experientially rather than simply numerically? And the reason I say the hook I might hang the arc of my career on about being human-centric, my interest in digital twins, although it's an area, a discipline that's often very focused on engineering, on mechanical and plant systems, on the kind of nuts and bolts of how a building is operating. Nonetheless, I'm very interested in how we as humans use the built environment, what we can measure about that, and how we can use those measurements then to do it better. How we can design better for our public, for our occupants, for our inhabitants. And one of the interesting things about user-centric design, the most important thing you can do is to ask your users. So actually, do you like this? Do you like that? What would you like to see done better, etc. It's something that we're doing very much in our software development work at the moment, and it's a practice that we're increasingly trying to apply to the built environment. But the digital twin comes in because it's also important actually to observe people when they're not thinking reflexively, when they're not kind of hyper-conscious or self-aware of what they're doing, because it's well established that people tend to experience the world differently when they're in the process of reflecting and speaking about what they're doing or feeding back what they're doing, as compared to just going about their business as normal. So I think both of those opportunities for learning about people, for learning about what they do in the context of the built environment are very useful. And the digital twin in particular provides considerable opportunities for understanding human behavior in the aggregate, sort of unconscious human behavior, and given the nature of the physical environment that corresponds to people's behaviors, how can we understand those correlations and do useful design work based around those?
There's often an underrated part of the design process is actually getting feedback after you've built the thing. It's almost never, it doesn't really exist at this point. Before
it does, but it is often difficult, and it's not. It hasn't been a standard part of the way that we and the other disciplines that engage in constructing the built environment, designing and constructing the built environment. It's not part of standard practice. So certainly it's by no means standard. There are precedents for it, but they are unfortunately rare, and we're aiming to make them more common.
So maybe to take a step back and ask you, for the audience that are watching this, maybe there's some young students who are you hear the term digital twin. How would you define the term digital twin, and are there different forms of digital twin? For example, here's a digital twin for maintenance, whereas here's a digital twin of the world for whatever reason. How would you define a digital twin?
So at its simplest, a digital twin is a digital model of something in the real world. And that thing might be an object or collection of objects. It might also be a process or a system of processes and objects. So that sounds fairly abstract. At that level it is. More realistically and more specific to the built environment, we are obviously interested in the data that is associated with land, with buildings. There's the generic term assets, which tends to cover them both. But it's the things on which and in which we live and work and occupy, and data about how those things come to be. So construction, digital twins have an important role in construction. How they operate, so how they are used, maintained. And I think often left out of that discussion, or perhaps a second-class citizen for some, but certainly not for me, is actually how they are decommissioned or disassembled or dismantled, and actually what happens to the building after it's a building. For sustainability, that's a huge concern. But I think there are other potential aspects where that information becomes relevant as well. And so you asked, and that starts also this idea that there's a digital twin that's relevant in construction. So you might think that actually all the constituent components, assemblies, raw materials that form a building might themselves have a kind of atomic twin. So your windows, your columns, your concrete that's going to become slabs, etc. Each of these things might have a digital being, a digital essence, a digital record of its being that then is joined, fused together, or accounted for in some way as it coalesces, as it gets assembled into the building that we're sitting in now, for instance. And then as those elements then eventually at some stage become disassembled, hopefully reused, potentially recycled, you could track the onward progress of those things, ensuring that they're complying with relevant sustainability guidelines or statutes or regulations.
Yeah. Maybe a follow-up question to that is, whilst there's no standard software at this point, for example, digital twins, do you see an kind of off-the-shelf platform that you see as the kind of home for the future of digital twins? For example, Unreal, like more and more people are building models on Unreal that could be used potentially as a digital twin for, connecting it to IoT and stuff like that, or the Omniverse, for example. A lot of people are experimenting with Omniverse. Is there a off-the-shelf tool at the moment that you see most used for digital twins?
Well, I think a lot of what is marketed heavily in the digital twin space at the moment is focused on the visualization of twins, which is important, critical even, but it is not all that there is.
Yeah.
And we are very much interested in the whole spectrum of digital twin activities, a lot of which has to do actually with ontology. So what are the elements, how do you define them, and importantly, how do you define their relationships within the twin? Right. Things like time series data, your IoT data, and then the visualization, and indeed not just visualization, but interaction with the digital aspects of the building. And that interaction is not only, potentially through a virtual walkthrough. We're very much interested in augmented digital experiences of the physical space. And it's something we've been producing a lot of and working through in our development as a team.
Yeah.
I think referring to what I said earlier about commoditization, it is often helpful when vendors in the market will make things that previously you had to do for yourself at considerable resource cost and considerable development time, when they make those things simpler and easier. So I do think, and some of your examples, there are already some systems that make some of those things easier, and indeed we are using them. People often speak of software as an ecosystem, and I think an ecosystem thrives when it has many participants that have a variety of different interactions with one another. So we would very much like to see, across all the software that we use, but in digital twins certainly, this ability for different systems to interact in useful ways, rather than looking for any one system to provide everything that we might need from that.
Yeah. Great. One question I was really interested to ask you, like Martha, is you kind of sailed through the parametric computational era and saw that evolve at a very unique practice that was at the cutting edge of this. Mm-hmm. Now we're here in this AI era, which seems to have a lot of parallels, but they're also two very different beasts. Do you see any parallels in the parametric computational era and the era we're in, let's say the AI era that we're in right now?
I see some parallels. I think both of them make digital manipulation of the models that we create, of our understanding of the built environment, both of them make that in some way more immediate, more accessible to designers. There is a way in which I guess you might say they act as a sort of force multiplier. So they make they offer the potential to make individual designers in some ways more productive. I think critically, AI, particularly with its interfaces that are oriented around natural language at the moment, but I think, I'm sure, increasingly we will see systems that are able to, for instance, interact with a user in almost a sort of napkin sketching mode. I mean, I know there are some systems that already do that, but they're not really commercial grade production ready at the moment, but they will come. And as compared to parametric design, it's potentially going in the other direction. I think parametric design helped some users, some designers, to think more logically, more abstractly about what they were trying to do, more on the meta level of what their design was trying to achieve, and how they could structure that as a system of rules that would operate on data parameters to bring about intended ends. I think AI is offering systems that try to infer what a user's wishes might be.
Right.
I do think to some extent, I mean, the title, the sort of job role, prompt engineer, suggests that actually what people are doing is thinking analytically about language and how the effects that language produces will change output, will result in desired changes to output. So at that level, there's still that structured thinking. Certainly, the engagement with that structured thinking as computer code, I think, is being pushed more into the background. I think there are good aspects to that, but I also wonder if some of the structured thinking that goes into making a computer program, when it is put through the channel of human natural language or natural modes of representation like drawing and sketching, whether some of that precision of thinking may be delegated to the computer rather than being actually taken on increasingly on the part of the designer.
Yeah, very interesting. Yeah, no, I think there is a real nice point that you're touching on there is like some of these tools give us the quick access to these things, but they take away sometimes that deeper thinking process.
Yeah, I'm Khaled. I'm part of the Applied R&D team. I'm a partner, and my interest combines some complex geometry, so I worked on like a lot of large projects in the past, and also robotics, which is like a personal interest of mine. I've been doing research in it for a long time, and performance-driven design. So some of the tools that I develop and I use daily are all related to how we can kind of find the best option, let's say, and how we can grade our designs in the office.
Sounds like you're covering some interesting areas, performance-driven design, robotics. We'll get into some of those, but maybe talk to us a little bit about performance-driven design, maybe from some young architects that are not sure exactly what that entails. What kind of things do you do with performance-driven design in terms of on projects? How does that actually work?
So for us, it's always a question of how you can rate your design option. So and it's like a long discussions as we have the teams. Usually is like we go through millions of options for each project, and the idea is you try to find criteria that you can grade your option in, and this will become like grading the performance of each option. And basically, you try to find, this comes through either analysis that we run, stuff like view analysis, performance analysis in terms of daylight, energy, and so on, or even stuff like financial data, like whatever the input is for each option, we try to find the best way to grade it, let's say.
Maybe let's talk about for performance in performance-driven design. What kind of tools do you use for that? Like, I know you guys will probably be utilizing Grasshopper and coding, but you guys have also built in-house tools, Dahlia, if I've pronounced it correctly. Maybe talk about some of these tools and how you use them.
So, as you know, we build our own tools in the office. This is something I've been doing for a long time. A lot of them are long-term developments. So, for something like Thalia, we've been doing, I think, for 5 years now. And it all starts with an idea and on a project, and then it takes its own life, and then we start having like a proper development life for it, that we can go through different cycles and so on. So Thalia basically tries to combine modeling and analysis in the same interface. So you can imagine somewhere that you can have direct feedback for whatever option you're modeling very quickly, and thus you try to get like through your ideas much faster, let's say. And this all started by the development of some of the tools that we're doing, like Cyclops and so on, some of the very fast analysis in combination of like gaming engines, technology, that meant that we can have analysis that needed like days, or a cycle that needs like 2 or 3 days to go through a specialist. Now you'll be able to just have that directly in your interface. And this becomes like what's the word? Let's say it becomes a power of this tool where you can discuss your options with your colleagues, for example, or discuss your options with the client directly while you can see all the performance criteria for the options that you're presenting, let's say.
You've essentially got a personal super assistant helping you whilst you're designing, in a way.
Yeah, exactly. It's, I mean, this is a good focus for us. We need to make sure that we're like producing the best option possible for the project that we're working on. And this also becomes a conversation, because there is never one option that's like covers all the criteria, right? It's always like a balance between 3 or 4, and then you need to make sure that you're presenting all of these in like let's say unified interface, that you can actually try to look at these options and see which one performs better for you.
So I see you're also involved in the robotics side, also specifically Spot the Dog. I've seen you in a few videos with the famous Spot the Dog. Maybe talk about why are architects experimenting with tools like, or robotics like Spot the Dog? What are you guys using it for, and where do you see it's advantageous for architects to utilize?
Yeah, I mean, robotics have been an interest of mine for a long time, and it's great to see how some of the technologies have evolved, let's say. Some of them is the way robots can really navigate space. So this is like the most important part that we saw in Spot and its development, for example. So it has been a problem for a long time of how any robot can navigate a space that the humans can use, and how it can actually interact with humans as well in the same space. And when Spotting came out with its abilities to like navigate terrains, go upstairs, and all this kind of stuff, we saw directly how it can be beneficial in architecture, for sure. And what happened is, all started with a conversation with a guy at Boston Dynamics in a conference, and then we got to the idea of let's try to test how we can use Spot for trying to monitor construction sites. And we started to build the idea of how we can use it around the construction site daily. Basically, you get a history of how the construction site is progressing through time, and then you can do all your checks on your BIM model later on, make sure that everything is built correctly, and if there is any problem, it's getting mitigated early on. So the whole idea for us was trying to build this workflow that like goes from scanning to checking the data against the BIM model, to getting a report at the end of it, and seeing how this all can be automated. So instead of having it, scanning the site once a month or whatever, or someone goes do it manually, something is done automatically every day. And then you just see the timeline of all the changes through the whole life of the construction site.
No, it's a very surreal thing to see it walking around. I'm still looking around to see if I might see it walk down the.
I mean, you can imagine the first time.
It's quite noisy, right? It's a machine.
It is a machine, and it's very weird, because when people see it, and we used to walk it around as well here, and at that time it was still a beta, so it was like there was, I think, 50 of them, and we had like one. And you can see actually lots of people coming to pet it all the time, taking selfies with it, even at the construction site. So it wasn't like intimidating by any mean.
Yeah.
I think the way it works and the way it's modeled around like all the canines that we like and so on, made it like a very approachable kind of machine. Then actually not that scary, let's say, even with noise and all the stuff that's around it. I think still works around humans quite well.
Yeah.
And this was also a surprise for us because we thought it would be, what's the question? How are the people on the construction side going to deal with it? Are they going to see it as a threat? Is it going to be like for them something that we're going to try to avoid or so on? But on the contrary, it was all, they all kind of welcomed it to the environment, let's say.
Yeah. Yeah, I think that's super interesting. We're in an era where I think obviously robotics seems to be on the rise with, powered potentially by AI. Do you think we'll see more robotics in the construction industry, particularly with the rise of humanoid robots where you have Tesla, Boston Dynamics creating more, human-like robots? Do you think we'll see that soon or in the not too distant in construction sites?
No, I think it will. It's more and more. You can see even I think HP now have a robot that goes around and can draw like lines on the site and so on. So you will see a lot of commercialization of a lot of these robots very soon. I mean, what everyone's trying to do right now is trying to find the best form factor for robots that can fit everywhere the humans does. So that's why a humanoid robot would work perfectly, because you don't have to redesign your process around it. It will actually like just get integrated in whatever process you have already. Right. Again, still the whole problem with navigation and computer vision is still like, I would say, the biggest hurdle. But with all the stuff we see in machine learning and so on, that won't be for very long. So I would say we're very near seeing this kind of robots around us. Construction sites, at home, definitely like it kind of will all come together, the machine learning bit and the kind of robotic advancement as well.
Yeah.
And I'm assuming this will happen like very near, like in the next 3-4 years for sure.
We seem to be at that inflection point of these two worlds marrying and taking off. So it's going to be an exciting future.
Yeah, you can see like autonomous vehicles, all this kind of stuff. Yeah, it's just you can see when you start having like, all these computers inside a car that can be controlled by an algorithm, and then all the stuff starts coming together. Let's say.
Yeah.
Hi everyone, my name is Marius. I'm a partner at the Applied R&D Team, where I lead the interoperability endeavors of the team and design collaboration, if you want to call it. But apart from that, I would say that I'm also like a jack of all trades. I've been using design computation for many years, and yeah, I mean, this practice and our team in specific is the best, let's say, platform to start experimenting more with technology within our industry.
I'll throw you a tiny bit of a curveball question to begin with, but I liked on your Instagram you have ex-architects, right? But you talk to us a little bit about your background. Like you trained as an architect, now you're more a coder developer side. Yeah. Talk to us about your background, and do you feel that now you've crossed the bridge of from an architect to like a developer, so to speak, or?
So yeah, I mean, I was originally trained as an architect, and then started, being interested into complex geometry firstly. So that's how I got into the world of, let's say, scripting first, and very old days of visual basing scripting, I suppose. But the reason why I have like ex-architect on my title is that I don't think I design in the same way as I did before, as I did during my studies, and as traditional architects are doing. Yeah. I do feel though that we design as well. Yeah. Being integrated into the project delivery process or within an architectural practice. Anything that you do, even as code, as writing code, at the end of the day has an impact on a building, right? So in that sense, I still feel that I'm designing, but not in the traditional way.
Yeah.
I would say that lately, yes, inclining more to software development. But again, this software development is very specific to the industry. Obviously, you might have heard before that we're using all sorts of technologies, from web technologies to film or game engines. So we try to integrate it within our tools. So it's a constant learning process, and that's the thing I enjoy more.
And computational design is one of those ones where it is design, like you said, even though you're coding or writing lines of code or even in Grasshopper, it's still having a big effect on the design. So,
no, absolutely, yeah. It gives you the opportunity to explore the design space. Firstly, a simple parametric model can give you thousands of options that you can then, if you choose, you can analyze and assess, and hence inform your decision making, right? It does have an impact, and I do believe that most of the current, let's say, young architects that join the practice, especially because the academia is also leaning towards, let's say, this field is maybe a little bit hot at the moment, or it is hot for 10 years now. They come prepared and they have an arsenal of tools that they can use, right? Yeah. So I would expect that every single member that joins any design team in the practice now has a basic knowledge of how to use visual programming interfaces like Grasshopper, for instance, and set up a very simple parametric model, or in a way, like take a parametric model from someone else, maybe our team, and start, adding to that or altering it or tailoring it to its own needs. So it's very important that, people come in with this skill set, because it also allows us as a team to focus more on what comes next, in terms of tools, in terms of processes, in terms of workflows.
So maybe talk about how do you work with the design teams and the projects? Is it like as simple as someone coming over and tapping you on the shoulder and it's like got a messy Grasshopper script, all the way from creating much more advanced workflows? How do you work with the teams, particularly with computational design?
Yeah. Well, there are a couple of scenarios in this case, but it's basically what you described. Like, people come to us with a problem usually, and they come to us to provide a streamlined solution to this problem. Maybe they know that we already have a solution, or they're engaging with us to create a solution for this. So that can happen like in the very first stages of design, or maybe on competition like stages, or it can even happen like later, like when you're creating documentation for construction drawings, for instance. The level of involvement that we have depends on many parameters. And the main one is, I would say, the complexity of the problem. Usually when we're involved in early stages, we tend to continue because we set up workflows for the team to work more effectively. Whatever these workflows might be, simple parametric models paired with analysis or optimization studies running in the background as each iteration of the design moves forward. But I would say that we would definitely like to be involved quite early, as we can provide this, let's say, feedback that is paired with data that come with it. So we can provide, let's say, like some sort of assurance that a design decision that's been made is supported. So usually it starts either with a form that they want to achieve, if we were to strictly talk about architectural geometry, I would say. and how it's better to achieve it, how we can integrate the fabrication constraints, let's say, how we can optimize it to be cost efficient. It's rare that we receive, let's say, workflows from our design teams because, as you may know very well, it's easier to build something from scratch rather than start tapping upon someone else's work.
Yeah.
And that's the beauty of the systems, right? There is a million different ways of doing the same thing, right? And then each one of us has, and within the team even, we have our own, workflows. We start from something else, but we always result to something that is similar, I suppose. So, yeah, I would be not against receiving parametric definitions from other people, but I'm a little bit too focused, and I would actually, this is not how I want it to be. I'm gonna change it a little bit. This is controlled by some data that I don't like.
It's like peering into someone's thinking process as well.
Yeah, exactly. No, it's as I said, there are a million ways to do the same thing. It's it's a deterministic process in the end, but the in between is something that is a bit hazy. I suppose.
So you mentioned interoperability. Maybe we'll talk a little bit more about that. I know you're involved in the development of Hermes, your in-house interoperability tool. Talk a little bit about what that is. Are we talking interoperability between Rhino and Revit, for example? What is the goal of it?
So, Hermes, if I were to give it, let's say, one line, description, this is more of a messaging service. It's cloud-based. It does interoperability at the same time because you can tap upon various proprietary applications. You can create clients for those, and you can send and receive data. So what Hermes does is basically connecting our designers, their machines, across the locations of our practice, real time and on demand, let's say. So it facilitates this exchange of design data. And it is very important that these data are very lightweight. They are also secured, versioned as well, so you can actually go back to something that you've done, let's say, a couple of days ago, and you have a version of this that actually works still, or you can audit, let's say, this data. So I would say Hermes is more the facilitator. What is important in this case is also the glue, or the language of data that are being exchanged with this system. And specifically for us as a team, they're very important because they connect our other products together. So it's one of our other products. I'm pretty sure Martha talked about some of those. They all speak to each other using this common language.
Okay, so it's much more broad. It's not like an interoperability between A and B. It's kind of agnostic of what you're working with.
There are many tools out there that do the interoperability side very well. And we as a team, we always keen on picking up tools that are already there and doing their job very well. Like for instance, Rhino Inside. We've been using it a lot. How do you integrate these tools in your workflows? And how you integrate these workflows with the design teams, and how you have this glue in between them that actually shares data is really Hermes' job. So we're not thinking in a traditional way of, I have a very complex geometry that's doubly curved. How does this become a Revit object? Right? This, for me, this is the easy part. What happens in between and how you can access this data is the it's not fun part, I would say, because it's more like a back-end infrastructure because no one sees it. And cloud infrastructure was also very tedious. But it's very important. And potentially it will be more important when we have a consistent, let's say, formatting for data in our industry, and we can train models.
Yeah.
And we can utilize these lightweight formats like other industries have done so far.
So we've been asking everyone that we go to from an incredibly broad perspective of the software that you use. So what do you use? Design, is it Rhino or Revit for BIM? But also specifically at Foster's, you have this incredible suite of tools. So maybe give us an overview broadly of the tools that you use, and also in-house the tools that you have to supplement them.
Yeah, I mean, obviously, CAD packages, if we were to cluster them or to like put them all in the same category, some of them are good. Some things, others are good at other things, and obviously Revit or BIM packages are very good at documentation, right? Design documentation. I mean, it's a no-brainer. You cannot really generate sheets, construction documents manually anymore. It's pointless. So, yeah, I think the office is using BIM a lot. There's a very big BIM team called BDS, Building Design Systems. But also, like, most of the designers are using Rhino for sketching, modeling on all levels, I would say.
Yeah.
And then comes the discussion how these talk to each other. How do we bring, complex geometric forms into something that can be documented, annotated, tagged, etc. So this is where the trouble happens.
Yeah.
And but that's, nothing we cannot solve, I suppose. Apart from that, I haven't really used any visualization software myself. I know the teams, every workstation of the technical stuff, design stuff, has some, let's say, rendering engines
Like Enscape,
installed.
Twinmotion.
Enscape might be one of the things more. So it doesn't really, it depends on the person, what they're comfortable with using. I wouldn't say there is like the recommended software. If you can make something look beautiful in one piece of software, there's going to be the opportunity for you to have the software on your workstation, for instance. And what we as a team are doing is trying to enhance the design experience really with our tools. So simply by bridging CAD packages together with Hermes, or providing an intuitive modeling interface with direct analysis with Thalia, or running analysis as you design with Cyclops in Rhino, or running optimization in the background with Hydra. So our tools are meant to come in the design process and enhance the capabilities of the designer. And ultimately, I would say, like, save time, allow the designers to focus more on what's needed in terms of the creative side of the process, and stop annotating, let's say, floor plans, for instance, right? I mean, I think most of the members of the team have the same belief as I do. Like, if you do something more than 3 times, you need to write something to automate it. I do have my own automations as I work, for instance. Maybe I'm too lazy or something. But that's what we're trying to provide for the whole office as well. Yeah. If something can be automated, we'll make sure that we pinpoint it, and we're gonna provide the solution to that. Again, we're trying to make the design experience as smooth as possible. Yeah. And as uninterrupted, undisrupted maybe as possible. Yeah. With our tools.
I think it's that nice. It's definitely a recurring theme of freeing up designers to spend more time thinking and less time producing or repeating things.
Yeah, absolutely. I mean, there are many talented people in our office and in other practices, and it's a waste for this talent to be
copying 1,000 trees around.
Exactly. Yeah. I mean, why would you copy that? There is a process of doing it automatically.
Yeah, yeah.
And obviously, like, new systems, hopefully large language models, maybe gonna assist this even better. if they can be integrated in these workflows.
The last closing question is, I know you teach as well at the Butler, right? What kind of advice would you give for a young, aspiring architect that may be interested in getting into computational design?
I would say that, computation, it's not, it has various, let's say, levels, how involved you want to get. For me, any student nowadays should have a basic understanding of at least parametric modeling. I think it's a great asset that someone that's going to go in a couple of months and a couple of years out in the market to look for a job can have, right? It's definitely appreciated, and sometimes it's required. No one, at least not in my knowledge, has gone into an interview and then someone told, oh yeah, you're doing parametric models? Oh yeah, we don't need that. That's not going to happen, right? So it's essential for me to have a basic understanding. Then how much in depth each person will go into that, it's up to them. Not everyone needs to be a computational designer or design computation specialist, or how's it called, specialist in any way, right? There might be some people that set up workflows, and you must know how to use them on how to make them your own. You don't need to set up everything from scratch. So I would say, as you learn other tools, it would be nice to start looking into these tools and this way of thinking, because it is a different way of thinking. It's not as intuitive as strokes on a drawing board, or pulling polygon meshes in other modeling software, for instance. So it is a more steep learning curve, because you have to change your way, the way that you design in a way, the way that you think. You have to think of the result first, and then how am I getting there, and plan this. But it's definitely very exciting. And for me, again, the most exciting part is that you can reach the same conclusion in a completely different way than others. It's a constant learning process, and that's why I also enjoy what I'm doing. Every day I'm learning something new. Every time our designers come with a different problem we haven't seen before. So it's very engaging. It's very engaging. I hope more people go into computation. More people save time for their colleagues. I would love to save time to my colleagues that are great designers, right? So my advice is just start picking up the tool, know how to use it in a basic level, and then decide what you want to do further down the line. But definitely pick it up.
Definitely get that computational grasshopper base.
The base is essential. It's a great tool to have. Even if you just use it to create folders in your machine, you can do it really. You can really do the simple thing. It also saves you time.
All right, guys, thank you for joining us on this ArchiTech tour, and a huge thank you to the Foster's ARD team, Martha, Marius, Khaled, Adam. You've been incredible. I'm totally blown away. I think what you have here is incredible. Stay tuned for our next episode, and if you enjoy this video, give us a like and subscribe, because it super helps the channel. Otherwise, we'll see you in the next tour.